So again, these two questions were like really very easy. The third question is a bit interesting though. Let's go through that. Okay, so I'll quickly explain what's going on over here. So in this case, what we are given is some number n. Let's not worry about that. And we are given an array of size 31. In this case, we are given some n. Let's not worry about that. And an array of size 25. So what does it mean? So we are given some array, and the question is to return a string. So in this case, as you can see, for the first input with the length of array is 31 and these numbers, the output for that is CJ quiz no BV something algorithms. And for the second input, the output is I don't know, served murder glyph or something like that. So this is what the problem is and how it's working, like how can we find the unique string. So let's understand that a bit. Okay, so essentially what they do is they choose some 26 prime numbers, because we have 26 alphabets in English, and they sort those 26 prime numbers that they have chosen, and the smallest prime number is given to A, then B, then C, and so on. Okay, now every number is having some identity with some prime number. So coming back to the string that we were having is CJ quiz bevy of DP plus algorithms, what they did was that they generated a lot of numbers. And now how are those numbers calculated? So the first number is nothing but the product of C and J. So in this case, as you can see, if I will zoom in, the first two characters are CJ. So the first number in our array will be the product of C and J. Now what does product of C and J means? Product of C and J means the product of the prime numbers they are mapped to. So in this case, C is mapped to 7 and J is mapped to 217. So the product of that will be 200 and something. So the product of that becomes 217, and that's why the first number is 217. What is the next number? The next number is nothing but the product of the second and third letters, in this case J and Q. So this was the question. So we are given an array of size n-1, and we have to print back the string of length n. Okay, so this was the question, and how to solve this is like really very interesting. So guys, the third question is a bit difficult to tackle, but just hold on with me for a while and you will understand what you have to do in this. Let's say we are having A, B, X, Y, R, T. Okay, now how is the encryption working? So we know that every letter is mapped to some number, and of course prime number, and we also know that A will be mapped to the smallest prime number, so then B, then C, and so on up to Z. So we have 26 distinct prime numbers with A mapped to the lowest one, and now we have to encrypt this A, B, X, Y, R, T. Now I am working in the reverse direction right now, because we are given the array and we have to decrypt to the string, but let's just understand what's happening. So now what they're doing is finally they're generating some numbers, right? So this string is having 6 characters, so the output array or the encrypted array will be having 5 numbers. And how the first number in the array is nothing but the product of A and B. And when I'm saying product of A and B, I mean the product of their primes, like A is mapped to some prime, B is mapped to some prime. Then we have Bx, then we have X into Y, then we have, I think, Y star R, then we have R star T. Now the interesting thing is that we are given this now, and we have to find out what was the original string. The problem over here is that doing prime factorization is like really costly, and I don't want to do that. I don't want to do prime factorization on n-1 numbers. It will be really very much costly. Okay, so what is the other motive, that what is the other choice that I'm having? So one of the intelligent things that we can do over here is, since we can see B is common in the first 2 numbers, then X is common in the second 2 numbers, then Y is common in the third 2 numbers, and then R is common. Let's say if you were able to find B. Now if I know B, I can divide this first number to get A, right? Then I can also divide this number by B to get X, and once I have X, I can divide the third number to get Y, then I can divide the fourth number to get R, then I can divide the fifth number to get T. So in this way we will be able to decompose all primes that could have been existed, and once we have done that, we know that the smallest one or the smallest prime is for A, then B, and C, and so on. So once we have done that, it's like really easy for us. We know for each element in the array what numbers what are the two primes from which it is formed, and if we know for some element what are the two primes involved in it, we know the two letters involved in it, and once we know the two letters, we can simply print out the string. So this is what I tried to do. The only catch over here is that the string can be something like AB, 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 C, X, Y. So in this case, as you can see, the first number of the array will be A star B, then it will be B star A, and then A star B, and so on. The catch over here is that the HCF of first two numbers will be the product of A and B both. And this is the catch that you had to catch over here, essentially, because the HCF of two numbers which are exactly same is the same number, right? So in this way, you are not getting the value of A, you are not getting the value of B, you are getting the product of A and B, and it's not helping. So in this case, what you had to do is finally down the lane you will get a different value as well. As you can see, we will at some point of time get the value of A star C also, and then we will also have C star X, and then we will have, I think, X star Y. So the important observation over here is that just ignore all the numbers till which they are same, and as soon as you find the next number is changing, as in this case A into C, this number is different from A into B, which are the first three numbers of the array, we can take the HCF of these two numbers to get the value of A, then we can divide this to get C, and we can divide this to get B, and we can divide this to get A, and we can proceed in the previous direction to get these values, and we can divide this bad boy to get the value of C. Once we have C, we can divide this to get X. We have X now, we can divide this and get Y. So now let me quickly go back to the solution. So guys, let's walk through the code and understand how it's working. At first glance, this things look like really very difficult, but it's not. It's looking very lengthy, but I will quickly make you understand why it's that, because the integers that we are working with are like really very huge and it will overflow in C++. So I have this struct begin that you already have in Java, or you don't have to care in Python, but for C++, this is some code that I frequently use in competitive programming. So if I close this, the code is like really small, so let me just create a fold at this line. I have forgotten how to do that. Let me think. So ZF and I think %. Alright, we have created the fold, and now as you can see, the code is like really very small, right? Really very small. So what we are doing is nothing fancy. We are taking input as the test case right over here on line 6. Then we are proceeding for every test case. We are taking input of the array. I am creating that array, and then what I'm doing is I'm finding the first two numbers which are different, and once I have hold of those two numbers which are different, I'm taking their HCF, as you can see on line 20 right over here, right? So I'm taking their HCF and I'm calling that B. Then I'm dividing the A pointer to get the value of A. Okay, so now I have those A and B, and I know that all the values before this are same. Actually, they're product of A and B, but anyways, so now what I am doing is nothing fancy again. So I'm creating an array fh. Let's just ignore the name right now. I'm really bad at naming, and of course it's a timed contest and I was like really very sleepy. In interviews, you should definitely not use such names. It will throw a bad impression, and if you are using such names, just have a short conversation with the interviewer that I'm just using them for the sake of ease of writing at good speed, but of course if it's production code, we will be using sensible names. And coming back, what I am doing is, I have taken the HCF. I know the value of A and B. I'm calling those variables XA and XB. I'm not sure why. Then what I'm doing is I'm having a set of begins, and I have put A, XA and XB right now, because ultimately I will get a collection of 26 primes, because you have 26 alphabets, and I'm having a set which is ordered. So I know that the first element or the first prime number in S after the processing will map to A, and so on. So that's why I'm having a set S, so that I will keep the numbers in sorted order. What I'm doing. Okay, so we were here initially in the starting of the array, and these numbers were same, so we hopped on, and then finally we were having those two elements which were different. We took their HCF and we found the value of B. Then we divide this number by B to get the value of A. And now what I am doing is so now we are having A and this is B, so we can use B to find out to complete this chain that we were having in the front of the array. We will take this number, divide by b, we'll get c. We'll take this number, divide by c, get d, and so on. So that's the whole procedure that's happening over here, and nothing fancy. So now I was having this set s, which was having all the list of prime numbers in a sorted order. Now what I'm doing is I'm mapping all those big numbers to basically 1, 2, 3, 4, 5, and so on, which I will be using to finally print the string, which I'm doing over here. So I'm iterating on the array that we have built, which was found by the decomposition of the array. And for given big integer, we know that it is mapped to some h of xx, and I'm adding 64 to it so that to convert it into the ASCII value of char, and simply printing that. So I hope this was a fun problem. I really enjoyed solving that. The fourth problem I couldn't solve at that time. I was a bit sleepy, so that's what I have to do now. That's what up solving is all about, and that's what will improve me as a programmer. So if you were not able to solve the third problem as well, it's good that now you have an idea. So use the hints or use the direction from this video and try to solve the problems that you were not able to solve, and try Google Codejam. It's not that tough. It will be a good experience for you, and it will boost your performance seeing that you are able to solve problems in Google Codejam. I hope this video was fun, and I will see you next time. Till then, bye bye.